All right, Jim, what are we talking about?
So we're talking about interesting things that happen at HPE Discover 2025 in Las Vegas.
Yeah.
So interesting. The keynote was really big on the new sort of three-legged architecture for AI solutions. Of course, it's about AI, and it's one of the legs of the stool I found really interesting. They really emphasized HPE Aruba networking as an essential piece.
Yeah.
Talked about how critical that is. It's good to hear that from them. And the other two were
Both AI, right? No.
well.
I'm kidding. One was AI. the other
AI
was
shows up
hybrid.
everywhere or throughout the stack, but I think it was GreenLake. It was the
Hybrid.
hybrid
Yeah.
Platform, right? And then AI on top of that.
Yeah.
So
And you see the whole
AI
floor. That's how the floor is divided. It's not just the keynote.
So there's three primary parts of their show floor. One's networking, one's hybrid, and one's AI. So it's interesting.
It's all you need: network, hybrid, AI. Yeah.
And then within networking, at least for my side of things, they had a separate session this morning. They talked about specific new announcements around that. There's some really cool things. They've actually converted on the Athonet acquisition and are making private 5G much easier to configure and integrate into a networking strategy, which is really good.
Interesting. What acquisition is that?
This was Athonet. It was a couple of years ago, private 5G, private 5G solution. One of the challenges has been it's a whole different set of technologies than Wi-Fi. People, especially in this community, in the enterprise community, are very familiar with Wi-Fi, but one of the barriers to entry has been how do you learn what you have to learn in order to set up and properly configure and organize private 5G? It's a whole different set of parameters, design objectives, operational settings. So what HPE has done is to say, okay, let's do that, but we'll do that in the background mostly and just present a pretty straightforward, relatively simple approach to setting this up, which will work for most people. Now, if you need to go behind the scenes and do something really special, you can still get there. But for the average enterprise where you're just trying to figure out how do I use this to complement what I already have in my Wi-Fi, it's going to be a really nice step forward.
Interesting. So what's the key use case of complementing your Wi-Fi with that?
Well, it tends to be covering really big areas where it's impractical to deploy Wi-Fi access points. So this is, so one of the examples are big warehouses that have a lot of moving vehicles, robotics, or things moving around. Wi-Fi is always challenged by roaming, meaning that when you have something that moves between one access point and another access point, it's rough sometimes, and oftentimes you don't get a smooth handoff and you get drops as a result. Well, when you can put up like one or two Wi-Fi or 5G antennas and cover an entire warehouse, where you would need, on the other hand, 30 or 50 or 100 Wi-Fi access points to cover that same space.
So they just have a shorter frequency so that it goes through the walls easier?
Yeah, and it just has a broader coverage area, the 5G radios.
Yeah, interesting.
So the other is outdoor applications, where you're, for instance, you want to provide coverage of a construction site or a parking lot area, and it's just not practical to go set up wireless APs or Wi-Fi APs, but you need coverage.
So it opens up a whole new level of IoT use cases.
Yeah, it does. Yeah, and access in general. One of the cool things I ran into here was they have this gateway that actually allows you to use that 5G private network to allow endpoints to connect, but back to the core IP network. So they make it easy to connect both of these kinds of coverage and yet still get access to the same IT network resources.
So you have one set of security policies.
Yeah, yep.
Very
Consistent security, consistent access. Yeah, exactly. So that was one area. The other, of course, is the agentic approach that they're taking and the rollout officially of an agentic architecture. Proper agentic architecture, by the way Omdia defines agentic, which is reasoning combined with breaking down and subdividing tasks across multiple agents, having them do their own thing, return results, showing decision-making based on that.
Putting the human in the mix.
Yeah, putting the human in the loop, coming back and saying, here's what I found, and by the way, if I have it, here's a recommendation on how you could address this. So they did a couple demonstrations about that. Pretty cool stuff.
Cool.
The last one I'll say is the integration that they're doing with OpsRamp, which you probably spent some time looking at.
A lot of time.
Yeah. Well, let's talk about that next because I want to hear what you think about OpsRamp. But connecting the Aruba Network Central networking stuff with OpsRamp allows them to gather telemetry and feed it into the same analyses, but from non-Aruba gear, from third-party multi-vendor gear. So that helps with the reality of brownfield IT environments where very few of them are pure single vendor and you still need to operate them. And so this is a way to do that.
Yeah, it's a really nice bridge toward OpsRamp because I talked about operational excellence today with those guys. And, operational excellence is kind of a boring topic because, I'm a cool apps guy. So operations is, But the interesting thing is one of the guys came from AWS and he said, what do you think the secret sauce is to the success of GCP and AWS and Azure? It's that operational excellence. That's why they call it Ops Ramp, right? They're getting you on the ramp toward operational excellence.
Makes sense.
And the interesting piece is that they analyze data. So what you were just mentioning, third-party networking data, direct data storage, app response, anything. And they're basically data scientists. They see their idea is to detect symptoms, early symptoms of a disease, right? So they say, my eye's twitching a little bit, probably later I'm dead of a heart attack.
Hopefully not.
But the thing is, for a human,
early indicator of a problem.
yes, for a human, that's actually intuitive, right? But the thing is, you have to think of it differently. Think of it as a couple of terabytes of logs, and there is randomly something in there. It's not like a twitch in the eye. Humans, that's just the logs and logs and logs and logs.
To use another analogy is needles, are there needles in that haystack, right? Needles that I need to worry about before I jump in that haystack and stick myself.
You should, yeah. And yeah, and that's exactly the point. And what they are doing is they're trying to, with 5, 6, 7 years worth of data, operations data that they have gathered, identify patterns like, we were throwing numbers around, was like 50, 60% of recurring issues of a certain use case that they can just identify out of the box by grabbing these patterns from real life data.
Yeah. And there's some probabilities involved, right? Because as we know, every IT organization, IT deployment and application mix is different. It's unique.
It's all probabilistic.
It's probabilistic. There are patterns of behavior that they will share with other IT shops that these systems on the networking side, again, HPE Aruba Network Central is cloud-based and they're managing millions of endpoints with that. So they're getting a lot of operational data. And from that, you can say, okay, I've seen a similar failure pattern or problem pattern. This is how I know if it's fixed. This, over here, maybe that's the way to fix it. So it's really interesting to see that applying across domain. Which is more challenging.
Yeah, the interesting thing that you are mentioning, the probabilistic character, that's really that's why transparency and the human in the loop are so important. And the way they're building this is just like you can think of an agentic AI framework, right? They have individual agents responsible for certain things. And then there are also agents responsible for double checking other agents that they're not hallucinating, and doing all kinds of sanity checks. And because at the end of the day, it's IT operations, right? It cannot just remediate, but the key is to put the human in the middle, give the human something that they get trust into gradually. You put it on Slack and, your agent on Slack basically tells you, you need to restart this server for 5 minutes of downtime because, we came across those symptoms and in 85% of the times, they correlate with something bad later. Do you want to plan 5 minutes downtime tonight, or do you want to get woken up some other night? Right. That's generally how this works. And the way they explain this is you add more and more of those agents. They are specialists in all kinds of things, right? There's many subdisciplines of networking. There's many subdisciplines of infrastructure. They know the apps and how they respond. And the key is that you've done your homework and you get data from the entire stack. And that data is consistent and normalized, right? If you are separating logs and traces and events and profiles and everything else, you can't do it, right? You have to have that correlation first, because if you have to pre-correlate that other stuff, there's already correlation before the correlation, and then the space is endless.
Yeah. The interesting thing that I see also with agentic that's kind of inspiring as a path to like solve some of these hard problems is, if you do agentic the right way, you move the specialized agents to where the data lives.
Right.
So you don't have to centralize all the data to do the correlations, which is very, very expensive in resource and in real cost in many cases.
And in exposure.
Exposure too, yeah, exactly. You're shipping all that kind of, especially if it's proprietary data, you're shipping it around, and So data security is so important that agentic offers the opportunity to say, fine, leave data resident where it is. I'll put an agent there that can do analyses. I could just ask it, hey, run an analysis against this, look for a pattern, look for something that related to these other, key indicators, and tell me what you see from that perspective.
And this turnaround, you may get it right 60% of the time. Then you may add another agent to it that also observes data from another source or looks for a different pattern, and then you get higher and higher. The key is that the human, it's like a team member. Your team members are also not always right? A team member puts into Slack, you should be doing this because, right? And then you can either believe it or not.
And then everyone else in that Slack group says, no way, you're wrong, or hey, that's a good idea, let me look into that, right? And you go through and you figure it out. So I look at it exactly the same way. The concept of agentic sort of structure is new digital workers, not there to necessarily displace anybody, but just to do some of the hard cranking of things more quicker and more efficient, things that computing does well, which is, processing
abstract numbers.
Well, and just processing huge amounts of data to look for those needles in the haystack. Or then to say, is there any alignment, any correlation, trying to find those data relationships. It won't find them all, but if it even finds a few of them and helps you get there quicker, it's totally worth it.
Yeah, and you learn. And there's two other aspects to OpsRamp that I found interesting. One of them is they go further with the human in the loop. There were a whole bunch of these projects with reinforcement learning, and most of them have, or all of them that I know, have basically given up because they could not really assign the outcome to the action of the model, right? Because it's very hard to do. There's so many data streams, and you have to really have everything connected. And OpsRamp is basically, they're focusing on how to collect human feedback let's put it that way, semi-manually, right? Where the human has to basically confirm, yes, this worked out, Yeah. And so that's one of the things. And then the other thing that they're doing is real-time analysis, but including historical data. And that sounds easy, but it's not, because you have to continuously correlate the historical data with the data that's coming in today.
Right.
And that is very, very expensive. Like if you ran a large language, I don't know if they're using large language models for that, probably not, because it's more data correlation. But they're working on a way where you can actually do that, where the data that's coming in, the telemetry data, is continuously viewed based on the historical data. And then it becomes historical itself, right? At a very soon point. And you can imagine how that's expensive to do. But once they have done that, you learn from your past mistakes. It's the logical endpoint.
We should mention a couple other things that I think were interesting here. One of our colleagues has already left, but on Scott Sinclair's behalf, I will say they did make announcements about the Electra storage and adding an MCP server to the storage.
We add MCP to everything. I mean, do you have an MCP port?
No, but I probably should.
Yeah, you're behind the times.
But it's an example of, we have these components today, or we have special intelligent software today, and MCP represents an opportunity to build an interface. It's an alternative to what have been typically used as API interfaces, right? APIs. MCP is potentially a faster way to connect things together, where you let the agentic architecture do the data reconciliation by contacting the MCP server, learning what's available, adding that to the knowledge model,
Yeah, and then querying it whenever it's needed.
Right, and then and of course they're doing other things within the data tier with the electric storage to make data ready for access via this MCP interface.
What would
So
be
they're doing
others-
some optimizations
Are
there.
those use cases, they're not purely operational, right? Or are they purely operational?
Oh, no, it's not all operational. I
Yeah.
mean, but it, yes, including operational.
Right.
Yeah. I mean, I think most of the immediate, obvious use cases for all this agentic AI is to improve operations, improve
So
resilience,
fine.
improve.
What can
yeah.
I do? I mean, in terms of improving, so that MCP server, basically, maybe I'll give it the rights to view my, I don't know, something, my private folders or my inbox or
Yeah.
something else, and then it can actually include this data when it does its analysis.
Yeah. And the more data, the more.
Yeah. So it can do even stuff like, Torsten is writing an angry email to Jim, and 10 minutes later, usually the server crashes. I mean, it can be stuff, again, data scientific stuff.
It could be. Actually, I think some of the really interesting future use cases, well, by the way, one of them that I think will get a lot of attention really quickly is security use cases. So they even did at this event part of a demo that showed on the network side, let's look at any unusual external exfiltration type data. Right? And so they drilled into one end device, and it's got, for some reason, it's doing a little bit of FTP traffic to North Korea. Okay, that's a concern.
How do you do that with MCP?
But this is one of the MCP, but you can have a system that is constantly looking for these unusual patterns, an agent that's always watching for these, and then giving a heads up when you see this kind of activity. That's not an unusual thing.
That's a great way when somebody asks, oh, do agents replace humans? I said, no, because that agent, it's like the most patient human in the world, looking for the tiniest signal, because an agent doesn't charge me per hour. I mean, maybe it does a little bit for the data throughput.
There's a resource cost.
It can stand on that corner, and all it does is check for one little signal out of 1,000, right? But it's still worth it.
Still worth it. You find that and you catch it early, and then you have a quarantining process built around that. When you see one of these, boom, you could save yourself from all sorts of trouble. The other area I think it's going to be really interesting is deployment, sort of like day one, so day zero even. If you want to say, okay, I want to stand up a new architecture for this application. Here's the kind of application. Here's the the networking needs. Here's the storage needs. Here's the CPU needs. Here's the software layer stack needs. Design a hybrid infrastructure for me. So I think we'll get to a point where systems are smart enough to say, okay, here's a sample design for you to use, and including all of the pieces of the stack that you'll need. So that'll accelerate deployment, day zero planning, and then day one when you're trying to deploy stuff. And then automatically set up and say, all right, I want to add these to my day two monitoring, platform too. Here's a new instance of a cluster that I want to watch, and here are the key things you need to watch on it.
I saw a slide during the keynote. I think they call it Green Lake Intelligence, that does exactly what you're describing.
Well, it's funny you should mention that, because that's exactly my point of one of the other things we should mention, which is Green Lake Intelligence, which tries to bring together that cross-domain viewpoint. Today, like I said, mostly operations use cases, but the future really holds a lot for the day zero, day one type use cases too.
Fascinating use cases, right? You type, hey, I need a file server environment, or I need a blogging environment. And it knows, based on what it knows about your own company, right? And that's where the MCP comes in. Your own company, the policies of use, that it shouldn't put 25 WordPress servers in the backend or database servers for the WordPress in the background, but it's just a modest blog. So it will only pick from certain things, and it will only pick from certain clouds or from certain hardware.
Right, exactly.
So yeah, it's
anyways, interesting stuff. They've been talking about some other longer range things here too, like quantum.
But to go that kills me every time.
To go into that,
I like the conversation about, oh, we are planning on benefiting from it, but we don't want to throw that much money away on it. But hopefully IBM doesn't hear that.
Well, hopefully you don't all get entangled and superimposed in the process, right?
but what do you think? I mean, I love the speculation, right? Like, our favorite example is always encryption and decryption, right? because it's like nothing. Once we figured it out, that's the interesting thing. We already believe that we know that once we figured it out, it will be like nothing. But when are we going to figure that out?
It's a really good question. Well, let's keep watching that space for sure. Yeah. Cool. All right. Well,
Yeah.
Good chatting. And it's been a good event here. Lots of interesting stuff happening.
It's been a fun show.
Yeah. Good. All right. Take care.
All right.
We'll see you next time.
See you next time.